this is where it happens. This is where we take all of the latest developments in our nanographic printing process and apply it to the systems and subsystems that are on the press so we can see how it all works together, how it all interacts. And this is the perfect place for me to be able to explain to you how our technology works. Because if you want to understand how Landa is able to achieve things that no other printing process can do, how we can achieve amazing print quality, stunning colors, the incredible speeds that we do, all on any paper without primer or pre-treatment, you have to understand what makes us different. And it's our technology that makes us different. Because our technology is unique, we can do things that no other printing process is able to do. So what is it exactly that makes Landa's printing process different from any other printing process on the market today? Well, it's really two things. It's our ink, Landa's NanoInk, and it's the process by which we apply that ink to the paper. So I want to talk to you first about the ink, and this is it, Landa Nanographic ink, okay? So what makes it nano ink? It's that every single pigment particle in this ink is less than 100 nanometers in size. What does that mean? A nanometer is 1/1000th of a meter. So to put that in proportion, to give you some idea of that scale, I've got this little coin here in my hand. Don't know if you can see this, that little coin in my hand. Imagine that I had the planet Earth in my other hand, yeah? This coin, the planet Earth. The ratio between those two is the same scale, the same ratio as between a meter and a nanometer, yeah? Planet Earth, this coin, meter, nanometer. That is the size, that's the scale that we're talking about. All of the pigment particle in this ink is incredibly tiny, yeah? We're talking about a scale of hundreds of atoms in size. So what? Why does it matter that our pigment particle is smaller than any other pigment particle in the industry? For that, we need to get in a little bit of mathematics and to understand the relationship between surface area and volume. So the smaller an object becomes, the greater the ratio of surface area to volume. Now, don't worry, let me try and explain that using this. This cube, imagine it was a pigment particle. It has a certain volume and it has a certain surface area. Now, if I do that, I've got the same volume. I haven't created more pigment particle, exactly the same volume, but just more surface area. And then if I do that, I've got even more surface area, but still the same amount of volume, the same amount of pigment particle, just loads more surface area. And if I was really dexterous, I could probably do that again, but I'm not, so I can't, and I won't. So the first thing that we need to understand is that the smaller you become, the more surface area there is in our pigment particles for the same amount of volume. And that's important because it's the surface area that absorbs the light. And the more light that is absorbed, the more vibrant, the more brilliant, the more intense the colors that you're able to achieve. So because we have loads more surface area, we're able to absorb lots more light and create incredible, dense, really vibrant colors. Those sort of colors that pop out and that make your print job stand out in front of your customers. So that's the first thing, the ratio of surface area to volume. The second thing we need to understand is that not all of the light is absorbed by the pigment particles. You really want the rest of the light to pass through the pigment particle. Unfortunately, some of the white light is reflected back. It's deflected back in a process called scatter. And generally, you don't want that because the more white light that is reflected back, it acts sort of like, imagine like interference between you and the colors you want to see. And it kind of makes the colors look a little bit faded and washed out. The best way to think about this is to imagine you were in a cinema watching a stunning blockbuster, lots of explosions, bright lights on the screen, everything happening, and then somebody walks in and switches the lights on. Suddenly all those bright lights, all of those explosions, they look a little bit more washed out, a little bit more faded. Why? Because you've got all of this white light between you and the colors that you want to see, yeah? Now, that brings me on to this. This is the only kind of bit of physics in this explanation. This graph shows you how much scatter occurs depending on the size of the pigment particle. What you can see is this shows you the size of the pigment particle and the amount of scattering that occurs. Now what this shows is that around 300 nanometers you have the most amount of scattering, yeah? And that's not a coincidence that titanium dioxide, which is the pigment that they use in white ink, that has a particle size of around 300 nanometers, because with white ink you want that white light to be reflected back. But what you can see though is that there's generally quite a high amount of scatter in this area, and that's roughly the area that conventional inks are operating in. So you get a reasonable amount of scatter coming back when you're using conventional inks. Landa's NanoInk, all of the pigment particles are less than 100 nanometers in diameter. We have zero scatter. So none of that white light is being reflected back. You're not getting any washed out look. You're seeing just the pure, intense colors that you want. And that's why we're able to create such amazing, such vivid colors that you'll see on our samples. So that's really what I wanted to say about the ink. Pigment particles are incredibly small, and that means we absorb lots of light at the wavelengths that we want, and we don't scatter back any of the white light, so nothing is washed out. The other important thing to know is that our ink is water-based. There are no solvents, there are no imaging oils used in it. It's all water-based, so it's very environmentally safe and good for recycling. One other thing I wanted to say about the ink, because the pigment particles are so small and we're able to achieve those brilliant, really intense colors, we don't need as much pigment to create the same color gamut as other printing technologies. So our dot size is actually half the dot size of a conventional offset printing process. So our dots are much, much smaller, and that has implications when we're talking about drying and talking about the speed of the press. So bear that thought in mind for later. Now, I said there are two things that you need to understand. The first is the ink, and the second is the process by which we apply that ink to the paper. Typically with inkjet technology, which is a great technology for imaging, the ink is jetted directly onto the paper. Putting wet ink onto paper causes a number of challenges, because that wet ink, some of it is going to soak into the paper, and the pigment particles are going to go below the surface where they're not effective, they're not doing the job that you want them to do. So you need to put down more ink so you've got enough pigment particles above the surface that they're able to absorb the light that you want. So you need to put down a thicker layer of ink. Now, if you're using a very absorbent substrate like an uncoated stock, then some of the ink is going to flow along the fibers in the paper, and those beautiful dots that you're creating on the page, they're going to get broken up, they're going to get distorted. The dot shape is going to be compromised, And the opposite, if you've got a very absorbent substrate, like a coated stock, then the ink is going to sit on the surface of the paper and not adhere well to it. And the dots are going to start merging together in a sort of a rivering effect. That means, again, you lose that integrity of dot shape. At the same time, if you're putting all of that wet ink onto the paper, you're going to be limited in the amount that you can put down, because paper doesn't like getting wet. And if you soak the paper with wet ink, you're going to distort the paper, and that's going to give you huge problems in terms of your print quality. And that means that you're limited in your area coverage, the amount of ink that you can put down. Another limitation is the speed of the press, because the more ink you put down, the more the paper has to be dried. And if paper doesn't like getting wet, it really doesn't like getting heated very suddenly. So you can't intensely heat the paper to dry out lots of ink. So you're again limited in the amount of ink that you can put down, and limited at the speed at which your process can operate, because you've got to dry out all of that ink. So to summarize, inkjet has a lot of issues and challenges because it puts wet ink directly onto the paper. Landa avoids all of those issues in one very simple way. We never put wet ink onto paper. We jet directly onto the blanket. And here it is. This is a sample of what the Landa blanket looks like. And this blanket does one thing and one thing only. It's designed to ensure that we have perfect image quality every time. It's a hydrophobic material that is designed to hold each ink drop in exactly the position that it's placed on the blanket. The blanket itself is heated to around 74 degrees. Immediately it hits the blanket, the drop starts to dry and fixes it in place. So we maintain those beautiful dot shapes every time and form perfect images every single time on the blanket. It's like we only print on one substrate. We print on this blanket, and we have perfected technology, and we've perfected the process of printing on this substrate, on this blanket, and we can create perfect images every time we print on this. We then dry the image on the blanket, and only when it's completely dry and the ink quality is fixed in place, only then do we transfer it over to the paper. And that's the process that I want to show you now. So please come with me, and I'm going to show you a working model of the nanographic printing engine where we can see exactly how the process works. So come this way. So this is it. A working model of a Landa nanographic printing engine. We have all the subsystems here. You can see we have the print heads, we have the ink, And over here, we have a small section of the blanket, okay? Now this blanket is gonna go traveling underneath these print heads. The ink will get jetted out through the print heads onto the blanket to form that image, and it comes here. So let's see how that works. And Irina is gonna be our press operator today. So Irina, let's print. That's it. If you look closely here, you can see on the surface, there's a faint image, but you can't really see it very well. Why? First of all, that image is incredibly thin. Remember, it's only half a micron thick. And because it's nano ink, it's absorbing all of the light, or the light is passing straight through without any scatter and being absorbed by the black blanket behind it, yeah? So you can barely see that image here. Now, we're gonna use our very sophisticated drying technology. Again, because the image is so small, so thin, you really don't need a lot of drying. We're just using a hairdryer, standard hairdryer. And then, I have to assist here. Just hold that. Again, very sophisticated technology. This is our impression drum. Yeah, just contact between the paper and the blanket, and that's it. Look at that. That's completely dry. Yeah, the image comes off the press completely dry. There's nothing you can do to smudge or smear that. And look at those colors. That image that you saw on the blanket there, that's now those amazing Landa NanoInk colors. Yeah, you can't get anything else like them. Now, I want to show you that again. What we're going to do now is double that speed, 200 meters per minute, the equivalent of 13,000 sheets per hour. Irina, go for it. If you blinked, you missed it, okay? 200 meters per minute, 13,000 sheets per hour. Now, everything is exactly the same ink, the same print heads, the same blanket, the same sophisticated drying technology. And the same very sophisticated impression drum. And that's it. Again, you can see no smearing, no smudging, and the print quality is identical. The same ink, the same blanket, the same print heads, just running at twice the speed, and you get the same perfect print quality every single time. Okay, so like with all Get Good demonstrations, I want to show you that again, but this time really close up. So, Irina, let's print for the last time. There you go. Now we use the same sophisticated drying technology. But this time I want to show you how the transfer process works. So come close and look at this. You only need to just touch the paper to the image and it's transferred and it's completely dry. As soon as the cooler paper comes into contact with the warmer ink, the ink chemically bonds to the surface of the paper and it's completely fixed in place. That's it. You just need to touch the paper to it and immediately the image is transferred over and it's completely dry. Now I know the question you're going to ask, what is left on the blanket after the image is transferred? So Irina, can we just remove the rest of this image? So there you can see we've just taken off the rest of that image. Now we'll show you what's left on the blanket. That's it. The page is completely blank. All of the ink is transferred over to the paper. There is no ink left on the blanket. It's completely clean. And that's it, guys. That is the Landa nanographic printing process. Now, as I said to you at the beginning, if there's one message that I want you to take away from this, it's that Landa is able to achieve things that no other printing technology can do because we are unique, because our technology is different, and because we're different, we can get results that nobody else can do. And what makes us different from any other printing process are two things: the ink, the incredibly small pigment particles, that means we have really, really vibrant colors and dots that are half the size of conventional ink dots, and the printing process where we transfer the ink indirectly through the blanket to the paper. That means that we can transfer incredibly high image quality onto almost any paper-based substrate without primer or pre-treatment at incredibly fast speeds and in an environmentally friendly and sustainable way. That's it. Thank you very much. I hope you enjoyed it.